Hello, so this is a revision video for AP Chemistry 5.2, Introduction to Rate Law. A rate law is an expression that relates the rate of a reaction to the concentration of reactants. It is determined experimentally, not from the balanced chemical equation. So, for a general reaction such as A plus B going to form C, the rate law would be rate equals rate constant K multiplied by the concentration of A raised to the order of reaction with respect to A, multiplied by a concentration of B raised to the order of reaction with respect to B. And the overall order of the reaction equals m plus n. The order of reaction with respect to a reactant tells us how the rate changes as the concentration of that reactant changes. In other words, it tells us how the rate of reaction changes when we change the concentration of reactant. If a reaction is zero order with respect to a particular reactant, then changing the concentration has no impact on the rate of reaction. You could double or triple the concentration of reactant, but the reaction rate will stay the same. If a reaction is first order with respect to a particular reactant, if you change the concentration of that reactant, the rate will change by the same factor. So, for example, if you double the concentration of reactant, the rate of reaction will also double. If a reaction is second order with respect to a particular reactant, now if you change the concentration of that reactant, the rate of reaction will change by that factor squared. So if you were to double the concentration of reactant, the rate would quadruple, because 2 squared equals 4. Equally, if you were to triple the concentration of reactant, then the rate would increase by a factor of 9, because 3 squared equals 9. Orders of reaction can be determined using graphs of experimental data. We can measure how the initial reaction rate changes when reactant concentrations are varied. The shapes of these graphs can identify the reaction order for each reactant. We can determine orders of reaction using experimental data by comparing how initial rates of a reaction change when a concentration of reactant is also changed. For example, in the table shown, we can see that for the reaction A plus B going to form C, the reaction is carried out 3 times, each with different concentrations of reactants. In the first experiment, the concentration of A and B are both 0.1 mole per decimeter cubed. However, in the second experiment, the concentration of A has been doubled, but the concentration of B has remained the same. But the rate of reaction has also doubled. This means the reaction must be first order with respect to A, because the concentration of A was doubled and the initial rate of reaction also doubled. First order. Experiments 2 and 3 both have the same concentration of A, but the concentration of B has now been doubled. But the rate of reaction has quadrupled. So the reaction must be second order with respect to B, because the concentration of B has doubled and the initial rate of reaction has quadrupled. 2 squared equals 4. Exam tip here: the order of reaction with respect to a particular reactant isn't connected to the balanced chemical equation. You must use experimental data to determine orders, never just the balanced equation. The rate constant K is a proportionality constant in the rate law. The value of this constant is temperature dependent, and the units reflect the overall reaction order. For example, the units for K for a zero order reaction overall could be mole per litre per second. For first order, second to the minus 1. For second order, litres per mole per second. Exam tip here: remember, rate constant K is temperature dependent. If the temperature of a reacting system changes, the rate constant K will also change.